Hello and welcome back. This is going to be another tutorial on how to use tree substitution. I've already done one on secant, so this is the second of the lessons. And this one is using the trig substitution of sine. You do not use trig substitution every single time. You only use it in circumstances. Generally, when everything else fails, you can try trig substitution if you realize you have the square root of a number, all right, minus the number. So you have the square root of the difference of two squares. All right, and that's when you have that. So as you see my little cursor circling around here, that is what you're kind of looking for. But once again, you don't always have to use it. But when you substitution, all those others don't work out, you might want to try trig substitution. All right, so without further ado, let's see how we can do this one. If you try this one out, you try use substitution, it doesn't work, parts doesn't work, partial fractions, nothing works. I'm going to do trig substitution. This one, because we have 1, the difference in squares is 1 minus x squared. So a being the constant, u being the variable, 1 minus x squared. This is a perfect situation and where we're going to use the ratio of sine. Now, to figure out the sine, we're going to, once again, sine is opposite over adjacent. So our opposite is going to be our u, all right, our variable. And our hypotenuse, all right, is going to be our a value. Using the Pythagorean theorem, when we finish up our triangle, we can write the square root of a squared minus u squared. Okie dokie. So with this, let's look at our values and let's plug in for a and u. Well, right here, the first thing is we're going to try looking for substitution. So I'm going to look at this quantity, and I look at this. I'm going to fill in my marks. So the u, the variable, is always at the opposite. Okay. And if you remember, whenever you do trig substitution, the numerator is always going to be your variable expression. Secant, it would be hypotenuse. And we're going to do another one, which is tangent. Tangent is going to be opposite as well. So here we're going to have is u. So when you have to see this type of difference of two squares, use sine. Well, our u in this case is just going to be x, because that's what's squared. Our a value in this case is pretty simple. It's going to be 1. Awesome. All right. Now from here, we can also write out the square root of, and that's just going to be 1 minus x squared. So we filled in everything that we need. All right. Other key thing is when we have sine, sine comes from the trig identity, and we can figure out cosine, or sine squared plus cosine equals 1. So cosine squared equals 1 minus sine squared. So we're going to be using this in cosine also. So the first thing we're going to do is we're going to figure out a ratio for sine. Okay, so once you have this, you're going to take sine of the angle, and that's going to equal opposite x over hypotenuse, which is 1. So what do we just figure out? We figured out that sine of theta equals x. All right, sine of theta equals x. All right, and that makes a lot of sense. That helps us out because we are now going to use that and plug it into our expression. So we're going to have the integral. I'm going to have sine cubed of x. We have dx right there. Sorry, x theta. All right, theta. I'm sorry. We're going to have dx right there, which we will eventually have to get rid of because we need everything in thetas. And we have the square root of 1 minus sine quantity squared. All right. And we have that. Okay. Now, the last one is we have to get rid of dx. If you can't see that, we're going to get rid of dx. All right. To do that, that's a differential. So we're going to differentiate this. All right. So we're going to take this with respect to theta. When we do this, we're going to have sine of theta. Theta, what am I thinking? All right, derivative of sine is cosine of theta. I apologize. All right, cosine of theta. So this is the differential. All right, so we're going to now take the derivative of this with respect to theta, so you know what we're doing. All right, and what we have is that right there, and this is going to equal, all right, dx d theta. I didn't show this in the last tutorial because I just didn't. But now we're going to get dx by itself. So we're going to have cosine of theta d theta equals dx. And that is the key we're going to use. This is the other ones that we're going to use. So now let's plug that puppy in. So now we have the integral of sine cubed of theta. All right. And then we're going to plug in cosine of theta d theta in for the dx. On the bottom, I'm going to use one more substitution because I don't like this. If you realize over here, this is also a trig identity, and that equals cosine. So I'm going to put cosine of theta right here. All right, so from here, I'm going to simplify this, and I'm going to start changing colors to green now. So from here, I'm going to simplify. So now we have this and this will cancel out. And now I can rewrite this, all right, into the integral of sine cubed of theta d theta. And hopefully what we created is a simpler integral that we can solve. I think we have. When you have sine cubed of theta, for those that don't know how to solve one of these, this is a little trick. We're going to actually use one of our trig identities. We know that this can be divided into sine squared of theta, sine of theta, okay, d theta. From here, sine squared of theta, and the reason why we're doing this, we're going to use a little use substitution. We're going to know that's going to equal 1 minus cosine squared of theta using one of the trig identities, equals sine of theta d theta. From here, we can now use a little u substitution. All right, u substitution. So I'm going to say u is going to be my cosine of theta, and du is going to equal negative sine of theta d theta. All right, and divide by that. So negative du equals sine of theta d theta. Hey, that's what I have left over right here. So I'm going to plug that all in. So I have the negative just sitting there. I have my 1 minus u squared. And then I'm going to have, oops, not the negative. I'm sorry, just ignore what's happening. All right, right there. Where that negative came from, that negative came from actually this negative du. So I'm going to have negative du right here. I'll just write this out a little nicer. And now we're going to simplify this a little bit farther. Distribute this through. So we have negative 1 plus u squared. We got that. And that's going to be times du. All right. I think I did everything right. I think I got that. All right. Now let's take our integral. All right. What's the integral of 1 with respect to u? That's going to be negative u. This one right here is going to turn into u cubed over 3. And don't forget our c. Well, what is u? U is actually cosine. So we have negative cosine of theta plus cosine of cube theta all over 3 plus c. All that work. But we're still not done yet. Yes, I know. You're probably going through this tutorial saying, oh my goodness, I'll never be able to do this. You can do it. I believe in you. And so does your professor or teacher as well. All right, well, now let's look at here because we have to get rid of the thetas. Where do we go? Well, let's go back up here. What is cosine going to equal? Well, we can look at our little triangle here. Cosine is adjacent over hypotenuse. All right, so it's actually cosine is equal to the square root of 1 minus x squared. All right, so that's how we get that. So we look at our little triangle, cosine, and just so we know this, let's use purple. Cosine of our angle, look at our triangle, is adjacent, 1 minus x squared, over 1. All right, because that's our hypotenuse. And so it's basically square root of 1 minus x squared. So over here, I'm just going to take that and just plug it all in. Square root of 1 minus x squared plus, and I'm going to take this, the square root of 1 minus x squared. That's going to be cubed all over 3 plus c, bada bing, bada boom. Oops, hello, bad writing. I apologize. And that is our answer. Once again, there's our answer. Going through and using trig substitution, all right, with sine is whenever you have the square root of 1 minus x squared, or when you have the constant minus the variable with the difference of squares. All right, well, I hope this helps you out on how to use the sine for trig substitution. And I'm going to have one more tutorial on how to use tangent. So good luck and God bless in the rest of your problems.